Media streaming has taken the world by storm and is growing faster than ever before, even more so with the onset of COVID-19 pandemic. With an urgent need to bridge the physical distance between people, streaming is playing the most important role ever in the history of mankind. Live streaming is enabling us to witness virtual events, live auctions, conferences, and much more from the comfort of our living room couch. Hello, this is Rajdeep Rath, and today I'll be talking to you about the topic of media servers and live streaming. In today's session, we'll be taking a look at the following topics. We will learn what is a media server and how is it commonly used. We will take a look at the functional overview of a media server. We will try to develop a deeper understanding of the role of a media server and the whole process of streaming. We will then give a glance to the important terminologies of the streaming industry. And finally, I will give you a roundup of the popular media servers active in the market today. Defining a media server. A media server facilitates the distribution of audio-video content to its clients on request. And the term media server usually collectively refers to both the software that performs the function and the hardware or virtual machine on which it runs. So that's for the definition, but let me try to explain it a little better. Suppose that you wanted lots of different people to be able to see the live stream that you were broadcasting, and each of your intended audiences uses a different type of device, lives in a different country, has a different type of internet connection, and so on and so forth. In this case, you just need to send the stream to the media server and let it handle all the complexity of delivering the stream. The media server will take care of packaging and distributing the stream to different type of clients on its own. Isn't that amazing? Now, coming to common applications of media servers, you would usually see media servers being deployed in two kinds of usage. The first one is for live streaming, and the second one is for streaming of pre-recorded content, which is also known as video on demand streaming. A live stream is usually something that is captured through a capable audio-video device before being encoded and sent over to the media server for distribution. Good examples of live streaming would be conferences, live auctions, and other live events. VOD streaming, or video on demand streaming, refers to streaming of pre-recorded media files. And good examples of VOD streaming would be consuming your favorite TV shows on your favorite OTT platform on the internet. So here we have a simple diagram that gives us a high-level overview of the media server's functionality in terms of media delivery. So as you can see, the media server sits right between the publisher and the subscribers. The publishers can be of two types here. The media store represents a VOD publishing source, and the publisher represents a live stream publishing source. So in both cases, in order to reach out to the intended viewers, the stream is first broadcasted to the media server. The subscribers then request the stream from the media server, and the server packages the stream and then sends it to the requesting client. This also shows us that the media server acts as a single point of failure in such a system. What that means is, if the server goes down, so does every stream between every publisher and subscriber. Now, there are many ways to deal with such situations, but that is a story for a different day. Now let's dive a little deeper and try to understand how exactly the streaming happen and what are the active roles played by the media server in all of this. The following diagram is a basic but rather detailed outline of live streaming involving a media server and the other components of the streaming system. So what happens here exactly is that a live event is captured to a capable audio video device. The data is then encoded by the encoder. An encoder can be a hardware or a software which is responsible for taking raw data feed and then encoding them for the platform using appropriate codecs. Now if you're wondering what is the meaning of encoding here and what are codecs, so codecs are like algorithms which is used to compress media while maintaining certain level of quality. The compression versus quality ratio of different codecs is different, and the process of using the codec to compress the stream is what is called encoding. The selection of appropriate codec for encoding also depends on the decoding cost and complexity that is put on the subscriber client. Once encoded, the stream is then sent to the media server. From there, different type of clients can request the stream from the media server. A typical media server can support one or more different streaming protocols for delivery of the media to requesting clients. Now, what is a streaming protocol? A streaming protocol is nothing but a standardized delivery method for breaking up the media into chunks and then sending it to the viewers and then reassembling it. For example, the protocol for delivering stream to Chrome browser client might be different than that needed to deliver the same stream to an Android or iOS mobile application. Normally speaking, in terms of a browser, the protocol used is HTTP and the streaming format used is called HLS, HTTP live streaming. And in case of mobile platforms, the preferred protocol is RTSP. A transmixer component aboard the media server usually takes care of packaging the media into an appropriate container which is suitable for the specific delivery protocol. Once the stream is delivered to the client will then need to decode the stream before being able to render it. This is where a decoder is required. A decoder is a component that sits on the client side, and it can be a software or a hardware based entity which is tasked with decoding the stream using the same codecs that were used to encode the stream in the first place. Now what happens if the client subscribing to the stream cannot decode the stream due to lack of codecs, or it is unable to play the stream because of poor bandwidth? Now that's where transcoding is used. Transcoding is a process of converting the media or stream digitally from one encoded format to another. This may involve changing one or more properties of the stream. The result of a transcoding operation is usually one or more streams, also known as transcoded streams, which are now perfectly compatible with the requesting client's conditions. And that pretty much covers everything I wanted to share with you on the anatomy of streaming and media servers. Now one last time, let's go over some of the important terms that we have learned in this session. So here we have terms at a glance. The first one being encoder. As I said before, is a software or a hardware entity that transforms raw data from source into an encoded format for transmission or storage using appropriate codecs. To match the encoder on the receiver side, we have the decoder, which is again a software or a hardware entity which is responsible for decoding the encoded data using appropriate codecs. And to make a point here, the decoder requires to have the same codec that was used to encode the media in the first place. Now codecs are nothing but algorithms for compressing or decompressing audio video data. Some of the most popular codecs used online these days would be H.264, VP8, AAC for audio, MP3 for audio, etc. Then we have protocols. A streaming protocol is nothing but a standardized delivery method for breaking up the media into chunks, sending it to the receiving side and then reassembling it there. Some of the common protocols used for online streaming these days would be RTMP, RTSP, and HTTP. HTTP is used as HLS, HTTP live streaming, that is, on Apple devices. Then we have transmuxing. Transmuxing is nothing but the process of packaging the media into appropriate containers, which is suitable for specific delivery protocols without changing any of the properties of the stream. So here what we have is, suppose you are sending in a stream and it is encoded in a specific codec, and we need to send the stream to two different type of clients which understand different kind of protocols, but they are both able to understand the codec in which the video was encoded. So in this case, we do not need to change any of the stream properties. We simply need to repackage the stream in a way that both the clients can consume it. So that is where transmuxing comes into picture. And the last one is transcoding, which is the process of converting a media or stream digitally from one encoded format to another. And as the sentence itself describes, this involves changing one or more properties of the stream. You use transcoding normally when you see that the viewer or the receiving side is unable to consume the encoded stream due to certain properties of the stream, such as maybe the resolution, or it may be that the color space is different, or it might be that the codecs are not supported on the subscribing side. So in this case, we need to transform the stream into a format that the subscriber or the receiving end is capable of understanding, and this is the process of transcoding. Finally, let's take a look at some of the popular media server softwares available in the market today. And here we have compiled a list of top known softwares for you, but I'm sure once you start exploring, you'll find a lot more. So here we have a small hand-picked compilation of some of the most popular and sought after media server products in the market today. The top half of the screen here represents some of the most popular commercial products in the market, and the bottom half of the screen consists of open source offerings. On the commercial side, we have Ant Media Server, Red 5 Pro Media Server, Wowza streaming engine from Wowza. We have Live Switch, Compunetics, Flash Phoner, and CBlue. And then coming down to open source offerings, we have Media Soup, which is add-on to Node.js. Then we have Jitsi, we have Genus, we have Ion, Curento, OpenWebRTC Toolkit, Lycode, and OpenVidoo. One thing to understand here would be most of these products, or should I say all of these products, are nowadays geared towards WebRTC, as that is the most popular mode of communication these days. But some of the commercial offerings also offer other protocols such as RTMP, RTSP, HLS, and so on. So that's about it from me for today, and see you in another video on another topic related to live streaming and media servers. Till then, this is Rajdeep Rath signing off. Thank you.